Good day, everyone. And once again, we are back together. And of course, we are continuing with inequalities. And today we are looking at quadratic inequalities. So if you haven't subscribed, please just make sure that you're part of the family. And of course, you can always get in touch with us. Our email address is info@mlungisinkosi.co.za. We've got a website as well. That's mlungisinkosi.co.za. And of course, you can always get hold of us and, just to ask about value-added services and inquire about many other products that we have. All right, so let's get right into it. Right, so today we've already started with inequalities and I've introduced it. If you haven't watched that lesson, please just go a step back and watch it. Okay, so we're looking at quadratic inequalities. Now, I'm going to just go back a little bit and just talk about, the quadratic function, right? So what exactly does it represent, right? So if we've got the function ax squared plus bx plus c, right, and we say is equal to 0. Now, what we can do is, of course, we can get the roots of the equation, right? In this case, we always factorize, or, we can use the quadratic formula. So supposing that we get the roots of the equation in this case, so we've got roots that we actually use. All right, so let's say that's x minus m and x minus n. All right, now when we factorize in this case, or we get the roots of the equation, what actually does it mean? So remember, if the value of a is greater than 0, meaning that if a is a positive, so the coefficient of our x squared, so that means that is a concave up parabola, right? Let's try and represent that graphically. In fact, you know what? Let me not draw the y-axis. Let me just draw the x-axis, right? So now what happens is that we can draw that parabola and it would look something like that, okay? So I want us to look at certain things. So in this case, what it means that is that we've got two roots in the equation. What are the roots? This is where the x values, or rather, let me rather say the y value is 0, right? As it is indicated here. Where is that parabola equal to 0? Well, it will be equal to 0 at x is equal to m, as well as at x is equal to n, right? So now we'll call those values the roots of the equation. Let's say, just for argument's sake, we know that m is less than n. So it means that n is the bigger value and then m is the smaller value. So this would mean that this is m here and this is n over there, right? Now, what does this actually say to us? It says before any value of m, so these are the x values, right? So these are the x-axes. So it means any value that is less than n, any x value that is less than n, so any value here, right? The y value that corresponds to that x value, so think about it, the corresponding y value there, the corresponding y value there, so all of those y values are positive, right? So any of those y values before the graph gets to m are positive, right? But now when we get to m, then it becomes, in this case, what we call our root. So at m, the graph is equal to 0. But then after m, then the graph becomes negative. It means that any y value, right, between these points here, at any value that is greater than m, in this case, the corresponding y value would be negative, right? And what happens at n? At n, we get the value to be 0 again. The y value is n, right? But then again, what begins to happen? Then the graph changes. Then any corresponding y value after that, right, is now greater than 0. So our graph becomes positive yet again, right? So when we look at that parabola, right, it tells us, all right, so from M going all the way that way, right, all the way to infinity, negative infinity, that is, right, our x value, right, for any x value from negative infinity all the way to M has got positive y values from the graph. Okay, so it means that the y values in the graph are positive all the way for x until it becomes negative infinity, right? And we know that our graph, as I said, okay, it bears repeating, right? Any corresponding y value here, right, where between m and n, right, any corresponding y value is negative at that point. So our graph becomes negative all throughout here until again we get to n. We said at n we know that that value becomes 0, right? And then y therefore becomes positive after n all the way up until infinity, right? Now to simplify this, we draw this as a number line, right? So, right, so if we were to draw this as a number line, we call the values of m and n the critical values, okay? So these are the values where the graph is equal to 0, right? So as a result, what we do to simplify our own lives, we just simply say, all right, so for any values between negative infinity, right, till m, we know that the graph is positive. Between m and n, the graph is negative, right? Between n all the way to infinity, right, we know that the graph becomes positive again, right? So now, should they ask me for which values, okay? So let's say we got x minus m, x minus n greater than 0, right? So remember, m and n are the critical values. So these are the values that we have over there, right? We call them the critical values where the graph is equal to 0. Now, this simply says to us, when we solve this, we know that x minus m, right, in this case, is greater than 0, or rather this graph, where is this graph greater than 0? We know it's greater than 0 from negative infinity all the way to m, right? We also know that it's greater than 0 from n all the way to infinity. So when we write down the solution here, we know that x would be an element of negative infinity. And remember, we said when you express this, negative infinity never is included. Why? Because infinity is never a definite value, right? So it will be all the way from negative infinity until m, right? But note, do we include m? No. Why? Because at m it is equal to 0, and they only said we want values that are greater than 0. So m would not be included, right? And okay, this means in conjunction with or together with, right? For all values from n, right? But remember, at n it's equal to 0, right? So we're not going to include that all the way up until infinity. Okay, so that is our solution. But now think about it. What if they had said to us, we want the solution for when x minus m, x minus n is less than 0, right? So what are we going to say? Well, where is this graph less than 0? So remember, where is it negative in this case? That is between the values m and n, right? So what would be our solution here? It means that x would be an element of m, so between from m, right, all the way until n, and that we do not exclude because it is simply less than. Okay, so what would be the difference if we had said less than or equal to, right? The difference is that then it means that we are including our critical values. So we are including the values of m and n. And so as a result, it means when we write down the solution for that, we would say x would be an element of m, right, from m all the way until n. Okay, and we are going to include those values, right? Now, what would be, another way of writing that? We'd say, well, x is actually less than, right? Now I'm actually giving the solution to this, right? X would be less than n, so it's between values where x is less than n, but x is greater than the value of m, right? So this would be another way of writing that down. On the other hand, if I were to write this, right, in inequality form, right, so I would simply say, well, it means that this is where x is less than m, right? So for all values of x less than m, or for all values of x greater than n. Okay, right. So in this case, that is how we would write that down. All right, now, so what I want us to do, ladies and gents, is just to look at some examples. You know how we roll, right? Let's look at some examples on how we're going to solve this. All right, now let's look at the following examples, right? So they say solve for x if, so we start with example 1, right? So we're going to follow all of these examples and we're going to try and do them together, right? All right, so the first one, okay, so we're working on the solution, okay? So the first one said, okay, we've got x squared minus 2x, which is less than 3. Now, the procedure is we must always try and put everything in standard form. So that's the first thing, right? So ax squared plus bx plus c. So this is going to be x squared minus 2x minus 3 is less than 0, right? And then let's find our critical values. So we're going to find where this expression, okay, will give us 0. So if we factorize there, what is it going to give us? We're going to have x and x, right? So there's our x and x there. So factors of 3 such that when we subtract them, so if you haven't watched our video on factorization, please do so. So that would be 3 and 1. Okay, so we know that in this case, it means that this bracket will be negative and this one positive. Okay, so this is why it was important for us to learn how to factorize. Okay, right. So now we've got our two brackets, so we can find our critical values. Our first critical value, remember you change the sign, is going to be at positive 3 and the other one is at negative 1. So we're going to put that in the number line form, right? So please remember this represents a parabola, right? So now we know that at our critical values, we put them in ascending order from the smallest one. So our critical value is at negative 1 and another critical value at positive 3. Remember, we place them in ascending order, right? So now, where is this graph? Remember, you imagine sort of a parabola, not sort of, a parabola, right? So imagine a parabola there, right? And in this case, what happens? We know our parabola between negative infinity, all right, to 1, to negative 1 rather, our parabola would be positive, isn't it? For all those values, our y is positive there. So it means for x values from negative infinity all the way to negative 1, our graph would be positive. So we know, I just want to remove this here so that we learn how to do this without necessarily having to draw this guy. So all you're simply going to do is that this is going to be positive here. This is going to be negative there, and that's going to be positive there, right? So what does this mean? Now let's find the solution. Where is this graph less than 0? Okay, remember, because we said it's less than 0, it means it will be, in this case, between 1 and 3. But remember, 1 would be a critical value. It would be exactly equal to 0 at that point. So we don't include it, and we symbolize that with an open dot. Okay, and then all the way up until we get to 3, again we symbolize that with an open dot. Okay, so now let's give the solution. So x would be an element. Okay, for consistency, let me use the same color. All right, so x would be an element of 1, -1, but we exclude -1 because it would be exactly equal to 0 at that point up until 3, and we exclude that value. Okay, that is our solution. If you want to put this as an inequality, in this case, what is our solution? It would be x. In fact, let me write this here. So x would be less than 3, but it would be greater than -1. Okay, I should be actually saying x is greater than -1 and less than 3. I hope that makes sense, ladies and gents. All right, now let's do the second one. Hopefully this will help in our solution. So we've got -x² minus 4x plus 12 is less than or greater than 0. I mean less than or equal to, rather. Okay, so there we have it. Okay, our solution. Okay, I just want to remove this one out of, get it out of the way. So we've got -x², negative x² minus 4x plus 12, okay, is less than or equal to 0. So the question is solve for x, right? Where is negative x² minus 4x plus 12 less than or equal to 0? Now, ladies and gents, when the coefficient of x² is negative, try and get it to be positive. But remember, in this case, we multiply by the negative throughout, so everything changes sign, right? So we're going to have x² plus 4x minus 12. Okay, so everything changes sign in this case, but remember, the inequality changes in this case. The sign of our inequality, it was less than, now it's going to be greater than. But remember, even if I were to multiply 0 by negative, it would still be 0. So in that case, it just remains as is, right? Now let's find again our critical values. We're going to factorize, right? Factors of 12, such that when I subtract them, they give me 4. In this case, that would be 6 and 2, isn't it? So that will be x and x. That would be 6 and 2. So we want our middle term to be positive. So in this case, it means that the bigger product is 6x. It would have to be positive, and so that one would be negative. Okay, right. For those of you who don't understand this method, go and look at our factorization video. All right, and we said this is greater than or equal to 0. So now we've got two critical values. That would be, remember, we changed the sign at -6 as well as +2. Let's draw the number line, right? So a number line, there it is there. Okay, we're saying we've got two critical values. A critical value is at -6 as well as at +2, right? So we want to know, where is this graph greater than 0? So that simply means that's plus, minus, plus. Okay, as soon as our a value is positive, we can simply just do this. Right, so now, where is this graph greater than or equal to 0? So in this case, I want you to note, it would be from 6, right, to -infinity, right? So you know it's positive here. And as well as we are including 2. Why are we including it? Because they said greater than or equal to. So now we are including the critical values, right? And in this case, it will be all the way till infinity, right? So now, to give our solution, okay, and I want you to be very quick about this. So in this case, we're going to simply say this is, it means that x is an element of, now you remember we start from the lesser value to the bigger one. So negative infinity would be the smallest. So that would be from negative infinity to negative 6. But what happens? We include negative 6. We show that with a square bracket, right? And then we know that from 2 all the way till infinity, right? So from 2, we are including 2, a critical value, because they said greater than or equal to. So in this case, from 2 all the way to infinity. We never include infinity, right? And of course, if you still don't understand this, it means you haven't watched our previous video on this part of inequalities. Just watch that first part. Okay, linear inequalities, that is. Okay, right. So we are moving swiftly. I hope that you understand that. Or, in fact, to put it in inequality form, we can say our answer, therefore, is x is greater than, or rather, let me say x is, let's start with the negative 6 value. X is less than or equal to negative 6, or x is greater than or equal to 2. I hope that makes sense, ladies and gents. All right, now we go on to the next one. Let's see what we had there. We were given, right, 2 minus x, x plus 4 greater than 0, right? Let's get this out of the way. So we've got 2 minus x, we've got x plus 4 greater than 0. Okay. Now, ladies and gents, you do not need to multiply into the bracket unless you've got a value that is not 0 on the other side, right? So the only time that you will multiply through the bracket so that you, you multiply the brackets together is when you have a non-zero value on the other side. So I'm not going to multiply in that case, but I want you to note you've got a negative x value here, right? So what would this negative x value do? If you were to multiply and say negative x times x, you'd get negative x squared. So what does that mean? It means that in this case, your value of a would be negative, right? So what we're going to do is we're going to try and get that x value to be positive, right? And what am I going to do? I'm going to multiply by a negative, right? So if I multiply by a negative in this case, remember what happens. I'm multiplying the left-hand side by a negative, but as well as the right-hand side, but the inequality changes sign, right? So in this case, I'm simply going, what I do on the left, I did on the right. So I can now change this bracket inside. If I multiply this negative through, this now can change into negative 2 plus x. But I'm going to put it as x plus 2. Okay, if you don't mind, right? So I keep this exactly the same, x plus 4, right? But now I'm going to say it's going to be less than 0. Okay, so in this case, remember we've changed absolutely nothing about this, right? Sorry, I made a mistake here. I was supposed to say negative 2 because negative 2 times positive, negative times that positive 2 will give me minus 2, okay? Negative 2 there. And then negative times negative x would give me a positive x. Okay, sorry about that. Okay, so now remember the inequality has changed sign. So what are my critical values? So we can draw that number line again, right? We're going to be quick about this now. It means that I've got x is negative 4. That's my critical value. and x is equal to positive 2, all right? So remember, you put that in ascending order. Where is it less than 0? So remember, we said in this case, all you simply do, that's positive, that's negative, that's positive. So where is this negative? Remember, less than simply means it's negative. It's negative, yeah. Less than means it's negative. So in this case, we are not including the critical values, right? So we know this is going to be an open dot here. So it's between -4 and 2. However, it's an open dot there, and it's an open dot there. So what is our solution in this case? So it means that we're simply going to say x is an element of -4. We are excluding it, so it's a round bracket, and to +2, and we are excluding it because it is a because it's not included in this case, so we put a round bracket. Okay, or we can simply put it this way: x is greater than -4, but x is less than 2. I hope that makes sense, ladies and gents, as we move swiftly along. All right, I hope that you've got that. So number 4. Okay, so we're going to our fourth example. Said we've got 4x squared minus 12x plus 8. Okay, all right, so we've got 4x squared. Okay, let's get this out of the way. 4x squared minus 12x plus 8. This is greater than or equal to 0. Right, so I can see I've got multiples of 4 there. So let's divide by 4, right? So this is going to be x squared minus 3x, okay? 12 divided by 4 is 3, plus 2, right? So in this case, remember, we didn't divide by a negative number this time. We divided by a positive, so the inequality stays as is greater than 0. Remember, anything divided, or rather, if we divide 0 by anything, it still remains 0. So that's why the right-hand side doesn't change. But it doesn't mean that we didn't divide it, isn't it? Okay, so, all right, and then we factorize again. Okay, so we're going to have that greater than or equal to 0. Okay, we know we've got x and x. Factors of 2 are 2 and 1. And in this case, we've got that positive there. It says the brackets have the same sign. And what is that sign? It's the sign of the middle term. So that's going to be negative and negative over there. Right, so what are our critical values? Right, that's going to be x is 1, positive 1 and positive 2. Okay, so our critical values, again, that's 1 and 2. Okay, so what does that mean? Means it's positive here, it's negative there, positive there again, right? So where is this graph greater than 0? Okay, in this case, it would be between -infinity all the way up until 1. So 1 is included, 2 is also included, right? So from 2 all the way to infinity, from 1 all the way to -infinity. I should be actually saying from -infinity all the way to 1. Okay, so in this case, what is our solution? Okay, I hope you are getting the hang of this, ladies and gents. X is an element of -infinity all the way up until 1, but 1 is included in this case, all right, as well as from 2, which is included, all the way to positive infinity, right? We can actually, again, put this as an inequality. This is going to be x is less than or equal to 1, or x is greater than or equal to 2. Okay, right, so I hope that is that makes sense. Okay, right, so let's go for the last one. Obviously, as per usual, I always give you guys something to do. So 2x squared minus 5x plus 2 greater than 0. Okay, so let's get that out of the way. So we're going for number 5 actually. Right, so we're saying we've got 2x squared minus 5x plus 2, which is greater than 0. All right, so now we're saying, all right, let's try and factorize this. Okay, so remember when you factorize this, I'm going to say that's 2 and 1. Factors of 2, that's going to say 1 and 2. I already know how this is going to look like. Okay, because when you cross multiply, 2 times 2 will give us 4. 1 times 1 should give us 1. And 1 plus 4 does give us 5, right? So it means our first bracket in this case, we should be very quick about this, ladies and gents. Once you're fluent with that factorization, it just makes mathematics much more pleasant and easier to do, right? Okay, so again, we've got negative and negative inside the bracket. So what are our critical values? So you think about it. So you've got 2x minus 1 equal to 0, or, sorry, I should have written x there. Okay, or x minus 2 equal to 0. So we know that in this case, you've got 2x is equal to 1 and x is equal to 1 over 2, or you've got x is equal to 2. Right? So your critical values, so let's draw a number line. Your critical values are at x is 1 over 2 as well as at x is equal to 2. Right? So we want where this graph is greater than 0. Okay? So we know that we're going to have positive here, negative there, positive there again. Right, our a value is greater than 0, so that's how it's going to be. Right, so in this case, what we're simply going to do is we say it's greater than 0 between negative infinity all the way to a half. So a half is not included because they just simply said greater than, right? So our critical values are not included. Okay, as well as from 2 all the way up until infinity, right? So now what we're going to do is give the solution, right? So x is an element of negative infinity all the way to 1 over 2, and that's not included, or x is from 2 all the way to infinity, and that is not included either, right? Or we can, again, x is less than 1 over 2, or x is greater than 2. Ladies and gents, I hope that makes absolute perfect sense. I really hope that you were able to enjoy that lesson. Now, of course, I can't just leave you without necessarily just giving you something just for you guys to try out at home, right? So this is the one that you're going to kind of give me an answer to, right? And in this case, please, when you give out that answer, so I am just simply going to say 3 into x squared minus 4, okay, to be less than or equal to 0. All right, please give us the answer to this one. Tell us in this case what your solution will be. All right, ladies and gents, I want to leave our lesson here. We're going to be talking about inequalities. We're going to continue so that I show you how to work with more complex ones as well. Otherwise, from me for now, I'll see you guys next time. Don't forget to subscribe and like and share. Tell your people that the uncle is doing the most. From me for now, it's sharp sharp.